Okay, let's continue this hardest exam questions. Today I'll be doing mechanics. Again, I'm using the same metrics to identify these questions. I've picked 5 here from a range of styles, and we will simply be tackling these questions. I'll be going through my thought process, my logic process, and how you should really be tackling them in your exam, and how you should be thinking about approaching these kind of questions. Also, again, at the end of this video, I will be talking about what actually is the hardest thing about learning mechanics, and that will be more of a philosophical talk. And so if you're interested in that and really understanding what you're doing here by learning mechanics, what kind of thoughts you're actually inhabiting and experiencing, then you should watch to the end. But anyway, we're just going to crack right into this and do these questions. So I have 5 questions here, and we'll start with this first one. Okay, so we have, what do we have? It's my pencil. Okay. All right, 3 particles A, B, and C of masses 5, 1, and 2. Okay, so immediately, I'm writing out what they are giving me. So the mass of A, the mass of B. The mass of A is 5 kgs. The mass of B is 1 kg, and the mass of C is 2 kgs. Lie at rest in that order on a straight, smooth, horizontal track. X, Y, and Z. A is at X, B is at Y, and C is at Z. Okay, so let's draw out what they're actually telling us. So we got a horizontal track. We got, say, A is here. This is A. Say B is here. This is B. Let's say C is here. It's just C. And this lie at the point X, Y, and Z. So this is X. This is no. And this is Y. And this is Z. All right. Particle A is projected towards B at a speed of 6 meters per second. Okay, let's write that as well. So particle A, its initial, so U of A is 6 meters per second. What else? And at the same instant, C is projected towards B at a speed of V meters per second. So at the same instant, so t equals 0, U of C will be V meters per second, but this is in the opposite direction, so it'll be minus V meters per second. Unless V is whatever, I'm just going to call it minus V. In the subsequent motion, A collides and coalesces with B to form particle D, and particle D then collides with particle C to form particle E, and then E moves towards Z. Okay, so we got A hits B, starts to move towards C, then C hits that new coalesced particle AB, which they're calling C. Those two hit each other, and then they all move together, particle E towards Z. Show after the second collision that the speed of E is 15 minus V over 4. Okay, so let's just sketch out what happens. So after this thing happens, we have A and B, they come together and they form D. And D will be moving at whatever, U of D. And then we have C, which will still be moving at U of C. So that's kind of the first collision. After the first collision, the instant of the first collision, this is the situation. The second collision, well, then these two things hit each other, and then we get this particle E with all of them, and we'll just call it U of E. They move at U of E, whatever that is. And then they move towards, they say that at the end, they move towards Z. So they're moving in this direction. Okay, so it wants us to show that after the second collision, the speed of E is that. So we want to show that U of E is 15 minus V over 4. Okay, so how do we do that? Well, this will be conservation of a momentum. So first, we need to find what the initial speed of D is. We already have the speed of C, and so then we can find the speed of U. by conservation of momentum. So first, number one, we need to find what U of D. What is U of D? And to find that, we know that the momentum, the initial momentum, because momentum is conserved, equals the final momentum. And so for this case, the initial momentum will be the mass of A times U of A plus the mass of B. So this, for this first part, because we're trying to find U of D, we want this so then we can find the speed of E, because then we can conserve the momentum again. Because the U of E, the momentum of D, plus the momentum of C will equal the momentum of E. Okay, so MAUA equals MBUB, because B is initially a rest, that will be 0, but I'll just keep it like that anyway. And the final momentum will be, we call it M of D, U of D. Okay, so this is 0, so we get the mass of A, so mass of A is 5 times the initial velocity of A is 6 plus the mass of B is 1 times the initial velocity of B is 0 equals the mass of D. The mass of D will just be, what's this coalesced particle, so it would be the mass of A plus the mass of B, which is 5 plus 1, which is 6. So this would be 6 times U of D, which we're trying to find. So therefore we get U of D equals to 5 times 6 is 30, is 30 over 6, which is 5. Just make sure of that, yeah. Okay, so 5 meters per second. Okay, we just need that. So now we have that. Now we can look at this second part as where these two things collide. So this is, after first collision, after second collision. Okay, so 2, we have again the initial momentum equals the final momentum, but for this collision, the initial momentum will be M of D, U of D, plus now M of C, U of C, which equals, because they all come together, will just equal M of E times U of E, or final, or whatever. It's just velocity. Okay, so the mass of D times U of D. The mass of D will be 5 plus 1, so it'll be 6 times 5 plus M of C is 2, and the initial velocity of C is V, or minus V, in fact, just moving the opposite direction. I don't know if it would matter if we do that. I guess we should say minus V, because V could be just negative. We'll see what this turns out to be. And the mass of E is just mass of A plus mass of B plus mass of C, so that's 5 plus 1 plus 2 is 8. So that's 8 times U of E. So we get 30 minus 2V equals to 8 UE. Therefore we get 8, UE equals to 30 minus 2V over 8. What do they do it? 15 minus, so yeah. So we can also write that like this, divide everything by 2. So therefore, that's your answer. So we proved that, so that's definitely right. Okay, B. Just hope that I've given myself enough space. Okay, B. The total kinetic energy of the system due to the two collisions is 63. The total loss, so okay. So loss of EK from two collisions is equal to 63 joules. So throughout this motion, when they collide, they're losing energy, and the amount of energy they're losing is 63 joules. Use the result from A to show that V equals 3. Okay. Well, we're probably going to have to set up an equation here for these energies. So we know that energy is conserved. So the initial energy, the initial kinetic energy, will equal to the final kinetic energy plus the energy lost. This thing. Right? We have an initial amount of energy, then the final energy of all of those, that moving, basically the E, this thing, that plus what we've lost should equal what we started with. That means that energy is conserved. So the initial kinetic energy will be a half mA UA squared plus a half MB UB squared plus a half, just summing up all those things, C UC squared equals to the final is just going to be a half ME UE plus this thing, which is 63. So let's just plug all this stuff in. So half the mass of A is 5. The speed of A, initial speed of A is 6. 6 squared plus a half. Well, this is going to be 0. We can write it in anyway. Mass of B is 1. And this is 0 because B initially is not moving. Plus a half of the mass of C, which is 2. But I'll just double check that. 2, yes. And the initial speed of C was minus V. 2 times minus V squared. This equals to a half. The mass, the total mass will be all of them, which is 8. And U of E, which was this. So 15 minus V, this will be squared, sorry. 15 minus V over 4 squared plus 63. Okay, so now let's just simplify this stuff. 6 squared times 5 divided by 2. This is 90 plus 0. And then this is plus V squared because negative will just be positive. And then we have here 8 divided by 2 is 4. So we have a 4 of 15 minus V over 4 squared plus 63. Well, let's just expand this stuff out. So we got 4. We can write this like this. We could also just take the 4 out. And that would be, you'd be taking a square out. But maybe that'd be too confusing, so I won't do that. Okay, so let's just work this stuff out. So 4 times, what is this? 15 over 4 times 15 over 4. This is 225 over 16 minus, we're going to get a minus 15, we're going to get a minus, well, plus 15 over 4 times minus V over 4, and then plus 15 over 4 times minus V over 4. And then at the end, we'll have this thing squared minus V over 4 minus V over 4 squared plus 63. Right, you're just expanding this thing. So 4 times 225 over 16. And this thing will be, so we get a what? A minus 15V over 8 minus 15V over 8 will just be minus 30 over 8. Just double check that. Minus 15 over 8. Minus 15 over 8 minus 15 over 8. Yeah, so minus 30 over 8, or calculate what it is. Minus 15V over 4. Plus, this is a V squared over 16. plus 63. Okay, times in by 4, we get what would be 225 over 4 minus 15v plus v squared over 4 plus 63. And on this side, we still have 90 plus v squared. All right, so let's simplify this stuff. Right. Guess I could times through by 4 to make it easier. I times through by 4, 90 times 4, this would be 360 plus 4v squared equals 225 minus 30 times 15 times 4. We're timesing it by 4 again. What's going on here? Does this work? Are you doing that? I guess I could just keep it like this. Let's just do this. So I'm just thinking like how to make it look easier to solve. I don't want to deal with all these fractions all the time. $360 plus v squared equals 225 minus 15 times 4 is 60 plus v squared plus 63 times 4 is 252. This is v. What have I done here? Oh, it's 15 over 6. This is wrong. 15 over 16. I times it in wrong. My bad. 15 over 16, negative 1 minus 15 over 16. So this actually be minus 15 over 8. So this will make this minus 15 over 2, which would make this 15 over 2 times 4 is 30v. Yeah, I plus 4 squared, I don't know why. Anyway, that's it, so whatever. All right, so now this will be 4. Just double check all this. So I have times 3 by 4. I'm doing that, I just don't want to deal with these fractions. It's just annoying to deal with them. So it'd be 360, take this over, plus 3v squared equals 225. 225 plus 252. 447. This is 477 minus 30v. Therefore, we get 3v squared plus 30v. 360 minus 477 minus 117. All right, and then I guess just minus b minus 30 plus or minus the square root b squared 30 squared minus 3 minus 117 over 2 3. So this gives us minus 30 plus or minus, what is all this crap? 3 times 117, that plus 30 squared, square root answer, it's a promising number, over 6. So we're gonna get v equals to minus 30 minus 48 divided by 6 minus 13, or v equals to minus 30 plus 48 divided by 6 is 3. Okay, and what did they? They wanted us to show us 3, right? Which we have done. And this first one is not possible. This is not possible because our V is supposed to be, we've said U of E is negative V. So if this is negative V, then it should be -3, which means it's moving in this direction. If it was negative, that means it would be positive and moving in this direction, which just can't happen. Just can't happen, right? Okay. Oh, I didn't give myself enough space again. Okay. Will I have to use this? Probably. All right, so V is 3. Okay, we showed that. And I haven't given myself enough space, so let's move this down a bit. How's everyone doing? Huh? Tell me, how are you? I don't want to like, oh, I'm good. Like, how are you really, you know? That's what I want to know. How are you really? Just tell me. Like, this should be weird, you know? I feel like people don't talk about it enough. Like, life and existing is just, it's a strange thing. All right, V equals 3. I might give myself a bit of more space here. But yeah, you're supposed to do all that. And we know that V equals 3. Just rub all this stuff out. Oh my god, I did a lot of calculating here. Okay, we did all of this stuff to get V equals 3. All right, that should be enough. Okay, that's B, C. It is given that the distance xy is 36 meters and the distance yz is 98 meters. This distance is 36 meters. And this distance is 90 meters. 98 meters. Okay, find the time between the 2 collisions. Find the time between the 2 collisions. So we'll be treating, so after the first collision, when A hits B, we then want to know, so that's the first collision, and then the second collision when C hits that new thing, D, that coalesced particle. So we want to find, okay, this is what we want to find. We want to find, so when this occurs, when these 2 things hit each other, this will be at Y. We want to know where, and this will be like, Z is like here, but this thing's moving at U of C. This thing's moving at U of D. So this is after first collision. We want to know where this thing is. Because if we know where this thing is, then we can find out the time it takes for this thing to hit this thing. So how do we do that? Well, we're going to want to know how long does it take, so U of A to hit B. So 1. I'm going to need space. So 1, so the time, so we're trying to find the distance moved by C when, or at the instant when A and B collide. Because if we find that, then we know where C is when A and B collide. And then if we know where C is when A and B collide, they're both moving towards each other at certain speeds, then we can find out how long that takes for them to actually hit each other. Okay, so this is X, this is Y. They gave us this distance, which was 36 meters. So this is 36 meters. So, you know, velocity equals distance over time. So the time, let's say, of A will just equal to the distance, which is 36, divided by the velocity of A, which was 6, I'm pretty sure. Velocity of A initially is 6. So 5 seconds. And at 5 seconds, where's C? Well, C has moved. C is moving at V, which is 3. So it's moving at 3 meters per second this way. And so the distance of C that C's moved is just going to be U of C times this time of A, which will be V, which is 3 times 5. So 15 meters. Oh, that's 6. Oh, I'm all over the shot. Okay, so that's 6. So that'll actually be 18 meters. 18 meters. Okay, so now this is our situation. Our situation is this. So when A and B together, D, and they're moving at U of D, C, which is moving at U of C, is moved 18 meters from Z. So this is 18 meters. So the distance between them now is going to be 98 minus 18. So the distance between them is going to be 80 meters. Okay, so we have okay, so we want to find when these two things collide. So the time it takes for them to collide. The time it takes for them to collide will be the distance, when the distance traveled by D plus the distance traveled by C equals to 80, right? Because if these distances, like let's say this thing has moved 10 meters and this thing has moved 10 meters, well, we sum up those two distances, that's only 20 meters. But let's say that this thing has moved like 60 meters and this thing has moved 60 meters and this thing has moved 20 meters, well, then they've collided because they're summing up to 80, which means they've hit each other. All right, I hope that makes sense. Okay, so this thing is U of D times the time that we want plus U of C times the time that we want equals 80. U of D was what? 5 meters per second. 5t plus U of C was 3, right? 3t equals 80. So we get 8t equals 80. So t equals 10 seconds. And that'll be your answer. That's like when it first collided, we're treating that point here, t equals 0. And then after that point, when they collide again and form E, that thing E, takes 10 seconds. So your answer is 10 seconds. So if you want to write it nicely, so time between collisions is t equals 10 seconds. Oh, it's probably going to be a long video again. Okay, so that was what? C, is there any more? CI, so that's CI. This is I. And this is II, which is only 1 mark, so hopefully it's not too bad. Find the time between the instant that A is projected from X and the instant that E reaches Z. So they're colliding. Where are they colliding? So where is this thing happening? This is Y, this is Z. Where is this thing happening? At 10 seconds, the distance traveled by D is 50 meters, right? 10 times 50, or 30 meters in, or 50 meters. I guess you could do 30. So this thing has moved 30 meters. And this thing has moved 50 meters, and it's now, this is the E here. This is your E. Okay? So that means that the distance between Z here, and E will just be 30 plus 18. So the distance between here, E, and Z, this distance will be this 30 meters plus 18, which would be 48 meters. Why am I doing that? I'm doing that because it wants us to find the total time. It was the time between instant A is projected from X and the instant E reaches Z. So we want to know how much time after that E is formed, that collision is formed, how long does it take to get to Z? And then we can just sum up the rest of the times and get it. So E is moving at, where's U of E? E is moving at 15 minus 3 over 4. So U of E is 15 minus 3, because we found that Z, over 4. So this is 15 minus 3 divided by 4 is 3. So it's moving at 3 meters per second. It's moving at the same. Okay, so the distance is 48 meters. And so the time, let's call it T of E, this time for E to get to Z will just be distance over time equals UE over D, which will equal to 3 over 40, no, would be D over UE. Yeah. So this is 48 over 3. 16 seconds. Okay, so that first bit is 16 seconds. So the total time, we should have all of it here. So we want the time to get to the first collision, which was how much? We know the time between collisions. We found that, which was 10 seconds. So this is going to be the time. Okay, well, it's going to be this. Oh my God, do I have to draw everything out? It's going to be the time that A hits B, this bit, and then when B hits C, so this is like T1, T2, and then finally when we have that E, when E reaches Z. So that'd be our T3, which is what we found here. So T1 plus T2 plus T3. So how long does it take for this to hit that? Did we find that somewhere? 6 seconds. No. Yeah, time of A to hit B was 6 seconds. Okay, the time of A to hit B was 6 seconds. The time between the collisions, so when D hits C, was 10 seconds. And then this final time here for E to move to Z was 16 seconds. So the total time will be 6 plus 10 plus 16. It's 32 seconds. Jeez. Okay, so the total time is 32 seconds. Alright. Let's keep going. I don't want to make this too long. It's probably going to be like an hour and a half. I have 5 of these things to get through. Anyway. The diagram shows the vertical cross-sectional XYZ of a rough slide. This section YZ is a straight line to incline an angle K. YZ is tangential to the curve. 8 meters. Mass of the child is 25 kilograms. Sine alpha is 0.28. The work done against the resistive force in moving from X to Y, so the work done against the resistant force is from X to Y is $50 joules. But it's against, so it'll be minus 50 joules. Right, this is the displacement. The displacement when they go in the opposite direction to each other. So the frictional force is acting this way, and the displacement is acting this way. So that means it will be negative. Anyway, okay, find the speed of the child at Y. Well, this just comes from, I have a video on this called the work energy question. This comes from, so the change in kinetic energy is the sum of the work done through its motion. So the speed of the child at Y. Does he start at rest? The section curve slides down starting from rest at X. Okay, so we've got our child up here. Starting from rest. Okay, so the change in K will equal to the work done against the resistive force plus the work done due to the gravitational potential on the child. Because the child will have a weight. Yeah, and so plus that. What is this? Well, we know this already. It's just minus 50 joules. But this thing here is just, well, work done is force times displacement, and the force is the weight. So this is going to be equal to W is equal to WR plus MGS. And our S between X, this is our S, is 1.8. So this will equal to WR plus MGS. The change in kinetic energy will be final kinetic energy minus the initial kinetic energy, which is the final kinetic energy, which is half m v final squared minus half m v initial squared, which equals WR plus MG sine MGS. Seems quite easy. How many marks is this? Okay. This thing is 0 because initial speed is 0. So we get half mvf squared equals to WR plus MGS. So we get, this thing is minus 50 plus m is 25, 10, 1.8, mass of the child is 25. This is a half of 25 VF squared. So we get minus 50 or 25 times 10 times 1.8 minus 50. This is 400 times 2 divided by 25. So we get VF squared equals 32. So therefore the final, does it want it in exact form? What does it want? Start. So square root of 32. So I'll just round it, 5.66 meters per second. Two. Three significant figures. Okay, B. It is given that the child comes to rest at Z. Use an energy method to find the coefficient of friction between the child and YZ, giving your answer as a fraction of its simplest form. Okay, let's just draw the situation. So we have this child, this is at Y? Yeah, this is at Y. This is at Y here. He's moving down this plane, and he comes to rest at Z. Is that what it says? He's giving the child comes to rest at Z. Okay, so then, and you know, this is alpha. This is the weight of the child. So this thing here would be alpha. We call this WX and WY. So I guess we'll just do the same thing. So changing K equals the sum of the work done. So what are the work done here? We have the work done against the frictional force. Work done against. F mu. The work done, we have the work done by the gravitational force plus the work done against the frictional force, right? Yeah. And the frictional force, so this thing, the work done, because what work done do we have involved here? We have the work done from the weight of the child, which is just going to be mg. We don't know alpha. So mg is just, we could call this, let's say, y. So this will be mg y times y, this distance between, this vertical distance between y and z, plus this thing, which is this frictional coefficient times the normal contact force, which in this case is Wy. So this will be mgy plus mu. Wy is just going to be, you resolve this vector, you get cos alpha equals to Wy over W. So Wy equals W cos alpha, which is W cos alpha, and W is mg. And then I guess we can find mu, right? Doesn't seem too bad. And the change in kinetic energy, again, will be half m v, u initial squared minus, final squared minus half mu squared. The final, again, is 0 because it's not moving at the end. So this is 0. And the initial will be this thing, his final speed at y. So this is going to be a half mv squared. equals to mgy plus mu mg cos alpha. What is y? Before we continue, y is opposite. Do they give us it? They give us this. They say this distance is 2 meters. So our y will be, so opposite over hypotenuse. So sine alpha equals 2 over y over 2. So y equals 2 sine alpha. So this equals to mg times 2 sine alpha plus mu mg cos alpha. We can cancel out an m here. We get a half v squared equals 2g sine alpha plus mu g cos alpha. We have everything, so we just rearrange for mu. So we get mu g cos alpha equals to 2g sine alpha, 2g sine alpha minus a half v squared. So therefore, mu equals to 2g sine alpha minus a half v squared over g cos alpha. Right? The final, okay. The initial won't be 0. Our initial is this. God, sorry for this, guys. All over the shop. The initial velocity is, I just got mixed up with the signs. So this is actually 0, our final velocity, because it ends at rest. So this will just be minus u squared. Minus u squared. Minus will give us a plus here. So this will be plus. Okay, so we plug all this in, we get 2 times, so this will be 20, 2 times g. Sine alpha was what? 0.28. 0.28 plus a half of v squared. This is 5.66. Is that right? 5.66. Yep. 5.66 squared. It wants it in exact form. So this is the square root of 32. So I'm just going to write, because it wants it as an exact fraction. So I'm going to write the square root of 32 divided by 10. If sine alpha equals 0.28, then alpha equals the inverse of 0.28. So then cos of that, so shift sine 0.28 cos answer. So if you put that in your calculator, you get 0.96 times 0.96. So square root of 32 squared is 32 divided by 2 plus 20 times 0.28. So this is 21.6 divided by 9.6. 9.6? Oh, this seems wrong. Nine over 4. What have I done wrong here? God. Oh. I apologize for this being so bad. This is mu. This thing here is the work done. I'm getting weight and work confused. This thing here is the work done by the frictional force or against the frictional force. So this would be this. This will be. I'm going to write like this. This will be this. Force times displacement. And this thing here we found before was this thing. This thing here is the force is WY. Was this normal contact force, so mu or mu n. Our n, our normal contact force, is WY. So this would give us, and WY was this mg cos alpha. Mg cos alpha. This thing times S. So this thing times S. And our S is 2 meters, because we travel 2 meters. So everything was right, it's just that there'll be a 2 here. So plus 2, I apologize for this, plus 2, 2. So this would be 2g. So this would be 20. So that gives us 9/8. So 20 times 0.96. 19.2. 20.21.6 divided by 19.2. Oh my god, 9/8. Should prepare more for this stuff. These are a little bit niggly. But I should be able to do this stuff no problem. So our mu is 9/8. Alright, let's keep going. Well, I want some more space, of course. Give me space. Alright. Might just take a minute now. Just, it's a lot of work here. Take a minute. How's everyone doing? How's their exams? You see, even I'm struggling. I should prepare more for these videos, but it's fine. Let's just keep going. So we got 3 more questions to do. All right, 3 more questions, eh? A particle moves in a straight line starting at O before coming to instantaneous rest at point X. At t seconds after leaving O, the velocity v, the particle is given by this. Right, let's write this stuff out. So we have v equals 7.2 t squared between these 2 limits. V equals 30.6 minus 0.9 t between these 2. I would recommend, if you're watching this video, to do the question first before I attempt it. And then see how our thought process, our mistakes, and everything, and like our answers, how they differ. Because obviously before uploading this, I will check that all these are right. I'm pretty sure they're all going to be right, but anyway. I don't want to get rid of that. Okay. This is as hard as it gets. Like, I looked through all the papers, like, to find these hard questions. So if you can do these, I mean, you're pretty much sorted. I mean, there's a bunch of way easier questions. These are as hard as you get from like years and years of past papers. So this is 9 marks. Where k is a constant, it is given there is no instantaneous change in velocity at t equals 8. Just the fact that they said that already, I'm like thinking I'm going to have to use that for some reason. Find the distance OX. Well, the distance OX will simply be the integral, because v equals dx by dt. So dx equals v dt. Integrate both sides. So the integral of x, so our distance is v dt. Sorry. Okay, so the integral between for this between 0 and 2, between 2 and 8, and this between 8 and above. Well, 8 until it comes to rest. Instantaneous rest at point x. So we need to find so one of the things we immediately need to find, when does the particle come to rest? Like, at what time does this come to rest? It will come to instantaneous rest when v equals 0. So when v equals 0, for this upper part, we get 0 equals to 1600 divided by t squared plus kt. Times through by t, you get what? 1600 plus kt cubed, 0. So you get what? T cubed equals minus 1600 over k. So t equals minus 1600 over k to the third. So at this time, so t, we'll call it t of x, this is where it comes to rest, this particle. So now we're going to need to find, k. Because if we find k, if we find k, then we can find where it comes to rest at x, what time, and then we can find the limit that we need to find from t equals 8 to what. And immediately I'm noticing, okay, so it is given there's no instantaneous change in velocity at t equals 8. So that means that, so as there's no instantaneous change in velocity at t equals 8, then we can say that the velocity here at t equals 8 will equal the velocity here at t equals 8. So this is for 2 to 8, we get at t equals 8, for t equals 8, what's the velocity? We get v equals 30.6. So v equals 30.6 minus 0.9 t. v equals 30.6 0.9 t. 0.9 t. So this would be 30.6 minus 0.9 times 8. So we get 30.6 times minus 0.9 times 8. So that's 23.4 meters per second. Okay, so therefore, for the t is greater than or equal to 8, we know that, for this thing, 1600 over t squared plus kt, 1600 over t squared plus kt, well, at t equals 8, the velocity is 23.4, and then we can find k. So we get 23.4 equals 1600 over 8 squared plus k times 8. So 1600 divided by 8 squared is 25, so equals 25. So 23.4 equals 25 plus 8k. So 23.4 minus 25 divided by 8. So k equals minus 0.2. Okay, so therefore the t of x, this point in which this particle comes to instantaneous rest, will be at minus 1600 over k, which is minus 0.2 to the third. That is minus 1600 divided by minus 0.2, cube root this. So it's 20 seconds. So at 20 seconds, this thing comes to rest. So if we want the distance OX, the distance OX will be the integral between 0 and 2 of this first part, so 2 and 0 of this thing, 7.2 t squared, 7.2 t squared dt. Oh. Yeah. And then plus, because it's different, like it's a different function for each part, between 8 and 2 of this 30.6 minus 0.9t, 30.6 minus 0.9t squared, plus the last part, which will be from 8 to 20, which we found there, where it comes to instantaneous rest, will be 1600 over t squared, or written 1600 t negative 2, plus kt, which is minus 0.2t. Minus 0.2t dt. Okay, so now we just find all these things. So, okay, we just have to do a bunch of calculation. So we get 7.2. This thing will be go up by a power, divide by the power between 2 and 0, plus this thing will be 30.6 minus 30.6t integrated minus 0.9t squared over 2. 0.9 over 2 is 0.45, so this will be 0.45 t squared between 8 and 2, plus this last one, which will be 1600. So it's go up by power, divide by the power. So go up by power be negative 1, divide by the power be negative t negative 1 or over t, minus 0.2 t squared over 2, which is 0.1 t squared between 20 and 8. And if we do all that, we should get our answer. So this would be 7.2. So it'd be, this thing would be 2 cubed is 8, so 8 over 3 minus 0. Plus this thing is gonna be 30.6 times 8. I'll write it all out. 30.6 8 minus 0.45, 8 squared. That thing minus 30.62 minus 0.45, 2 squared. That thing plus, I'm just wondering if I should write it all out or not, over 20 minus this over 20 minus 0.1, 20 squared. That thing minus 1600 over 8 minus 0.18 squared. Okay, so 7.2 times 8 divided by 3. The first one is, that first bit is 19.2 plus this thing 30.6 times 8 minus 0.45 times 8 squared. That gives us 216 minus 30.6 times 2 minus 0.45 minus 0.45 times 2 squared is 4 times 4. This is 59.4 plus minus 1600 divided by 20 minus 0.1 times 20 squared. Just minus 120 minus 1600 divided by 8 minus 0.1 times 8 squared is that 206.4 minus. Just gotta be careful with the signs. So we get 19.2 plus, oh my god, 9.4 plus 156.6 plus minus 120 minus plus 206.4 plus 86.4 plus 156.6 plus 19.2. So your answer is 262.2. So DOX equals 262.2. They give us units. Meters, and that's your answer. Okay, let's keep going. Okay, let's do this last question. I'm not going to do number 5. This video is already getting pretty long, but I'll have a worksheet where I've written answers for it. But it's pretty similar to this one anyway. There's just some slight variations, but it's a similar method, so you can see it necessary. Okay, so explains this diagram. Immediately I'm going to, so it explains this diagram and wants to find the frictional coefficient for the system at limiting equilibrium. Okay, so first of all, what we have to do here is we have to find what way this is accelerating, because that will tell us which way the frictional forces are acting. And to do that, so this is the way to be. This will be like a right angle triangle. This will be theta. We'll call this theta 2. We'll call this theta 1. So this will be, this bit here will be we'll call it WBX, and this will be WBY. I'm just labeling these things. This is WA, this will be WAX and WAY. So we need to find which component of their weight acting down the slope, which is larger. So for WBX, this is, so sine of theta 2, this is theta 1, theta 2, sine of theta 2 equals WBX over WB. So WBX is WB sine of theta 2. And this one is same thing, but sine WBAX over WA of theta 1. So this would be WA sine of theta 1. So we want to see which is bigger, so then it will tell us which way this pulley, incline pulley system is accelerating. So if we plug those into our calculator, so mg, so it'd be 6, so this would be 16 sine of 50, and this would be 12 sine of 40. 16 sine 50. So this is like 12.2, and the other one is 12 sine 40. This is like 7.7. So this is bigger than this. So that means that this is pulling more down here, has a greater force down. So its acceleration of this system is this way. Okay, so that being said, now all we need to do is resolve the vectors, resolve the forces around each mass, A and B, and we'll get an equation for mu. And to do that, so we resolve forces about A and B. And so if it's moving down this way, that means the frictional force of B, we call it F mu B, is acting up. And remember, the tension is acting in here. And this one is moving up. So that means the frictional force is moving down. Okay, so for the forces about A will equal to, and it's at limiting equilibrium, so that means that the acceleration is 0, so this thing will actually be 0. And the forces about B will equal to the mass of B times A. And so this equals 0 because it's at limiting equilibrium, so it's not accelerating. Okay, so what are these forces? Well, for A, we have the tension force is positive, acting up, minus these two things acting down, the frictional force and the weight W acting down the slope. So WAX minus the frictional force of A. That equals 0. And we also have for B, in this case, we have the weight Bx is acting down in the positive direction minus F of mu B acting clockwise, and the tension is acting clockwise. Okay, so therefore we can say T equals WAX plus F mu A, and here we get T equals WBX minus F mu B. Okay, and we know these things, so therefore we equate them together. We get WAX, because the tension is the same, equals WBX minus FUB. Okay, we know these things. Remember, WAX is WA sine theta 1. So this is WA sine theta 1 plus F mu A. And this is WB sine theta 2 minus F mu B. And for F mu A and F mu B, well, these are just going to be F mu A is just mu times this normal contact force for A, which in this case is WAY. So that equals mu WAY. And that will just be mu WA cos for A theta 1 of theta 1. And the same goes for F mu B equals mu N for B, which would be mu WBY. And that equals to mu WB cos of theta 2. So now we have this final thing. We have WA sine of theta 1 plus F mu A, which is plus mu WA cos of theta 1 equals to WB sine of theta 2 minus F mu B, which is minus mu WB cos of theta 2. Okay, so now we rearrange for mu. We get mu of WA cos of theta 1 plus mu of WB cos of theta 2 equals to WB sine theta 2 minus WA sine theta 1. Therefore, factor out a mu here. We get WB sine theta 2 minus WA sine theta 1 divided by WA cos of theta 1 plus WB cos of theta 2. We have all those things, so we can plug them in, and it wants us to find this mu. So our B is 1.6 times 10, so our weight of B, so 16 sine theta 2 is 50 degrees. So sine of 50 degrees minus A was 1.2, so that's 12 sine of 40 degrees 40 degrees divided by WA, 12 cos 40 plus 16 cos 60. And if you put all this stuff in, 16 sine 50 minus 12 sine 40 divided by 12 cos 40 plus 16 cos 50. You get 0.233. So mu equals to 0.23 to, I don't know, two significant figures. All right, I'm going to stop there. There is another one, but I'll do a written answer for that in the worksheet. I'm stopped because I'm a bit over this, to be honest. I've done already probably like an hour and a half of talking and teaching or whatever. There is this other one. It's a similar kind of system. It's like a pulley system, but I'll just have a written answer for that in the worksheet. And yeah, that's it. I will do another talk. I'll do an ending talk here on a deeper, sort of what I actually enjoy doing is like talking deeper about mechanics and what actually is mechanics and what you're learning here. So we'll do that right now. Okay, again, to sort of end this thing, like this hardest example, this mechanics thing that we're doing, like what is mechanics? What are we actually doing here? What are you actually learning? Have you ever just thought that? Like, what is it that you're learning? And I think in essence, again, I have nothing planned here. I'm just talking purely, honestly, and truthfully as I can here. Like, what you're learning here is basically these ideas, that causality is a real, truthful thing, that there's a cause of things and those things have an effect. And if those causes can, if you can understand what the causes are and how they affect the things that they're causing on, then you know what's going to happen in the future. And so basically what mechanics is really doing is it's giving you the concept that there's a future that can be predicted. Now, that's a very powerful idea, and in a restricted sense, it is what we do. We do that as a society, is that we predict, okay, if we do this, then this is going to happen. And we do that with projects, with so many things around you. All of the things that physically come to fruition around you are based on the idea, which I want to be clear, is an idea that there is a future which, if we act in a certain way now and we know the laws of the present moment, then the future will come to fruition in a way that we can already see now. That, in terms of very restricted and refined sort of environments and domains, is possibly true. However, in the grand scheme of things, is that actually true? What am I saying? Is causality actually real? You know, in terms of physics, like, okay, there's a pencil. It drops. I know how it drops. The cause is I let go of it. But then we could even go back and say, well, who thought to drop it? Where did that thought come from? Where did that come from? And depending on how much you back up this causal concept, it will get very, very shady and very, very weird. It's just like, well, did I come up with the thought to drop it? Now I'm thinking, don't drop it. You see, it becomes a bigger issue when we basically put the individual and consciousness into the mix here. As soon as you have things that are conscious, then this whole idea of things being causal or cause and effect becomes very, very shaky. And it's not so obvious that that's actually the case. Where do these thoughts come from? Where did the idea come from of cause and effect? Where did the idea come from for mechanics? All of the basis of mechanics in which you're learning. And all of these things become very shaky and very not understood. And really, mechanics is kind of an interlude into physics. And physics, as a domain of exploration of reality, was based heavily on cause and effect, mechanical systems defined, that we know the system as it is and we know the laws that govern it through time, therefore we know what it's going to look like in the future. Again, this is something that physics has used heavily and is extremely powerful in using that. But basically my point is that all of this stuff that you're learning within mechanics is based upon the idea of cause and effect, and knowing the laws of cause and how those laws affect, how they change the present to the future. If we record the present, we might know the future based upon physical laws. And I'm basically saying, as an idea, that is an idea. And that idea you should personally question may not be, and in fact, I know is most definitely untrue. That reality is actually not constructed through cause and effect. You could even have things like, and I believe this to be true, is that things within the future are affecting the present. They're sort of drawing it forward towards something. For example, if you've ever seen like those wells that, like, you know, you put a coin down and it floats towards the middle, it rotates circularly towards the middle, like as a really basic example. Like the future is that kind of embodiment of that whole where that coin is going, and is pulling its present moment towards the future. And so the future for you as an individual, for us collectively as humanity, this thing may be already being pulled forward. It's pulling it from a place which already exists. I mean, is the future something, I mean, when we get into cause and effect, I mean, I could talk about so many things. When we get into cause and effect, we're also talking about time. What is time? Time is some future, some past, some present, some constantly ticking thing. Is that what it is? What is it? Does it even exist? Is the future really a thing? Is the present really a thing? Is the past really a thing? Or do those things all exist within your mind right now, and you can conjure up different futures? You can restrict your past? Like what I'm saying is, like, as you start to question these foundations of anything of knowledge that your schooling system is introducing to you, as soon as you start to question them and critically think for yourself, you will notice very quickly, and I am here to aid you in that process, that none of this stuff is really understood, and it's way more mysterious than you really think. You don't know what time is, you don't know what cause and effect is, you don't know what space is, you don't know what you are, you don't know what reality is, you don't know how you got here, you don't know where you're going, you don't know anything. And I'm not saying that as a detrimental thing to your being and your existence. I'm saying that as a way to opening up your experience and having new knowledge that is grounded in mystery, not saying, oh, it's rubbish, but incorporating it into that unknown can be very beneficial for you as a being and as someone who wants to become highly educated. Anyway, I just thought at the end of this thing, I would just go on a little talk about mechanics and just as a domain of study, and this idea of cause and effect, this idea of time, of things being present, past, and future. I mean, it's already in physics very well known that time as a constant ticking thing for all people is actually not true. Your time may be different from my time just based upon, I mean, according to special relativity, based upon the speed that you're moving. I mean, that is just a little thing, as a sort of interlude into actually really exploring what it is already a profound thing. If you move faster than me, you will age slower. I will age faster, like something like this. I mean, these things it's very difficult, and physics and mechanics and mathematics do a divine job in trying to explore and explain and systemize this phenomenon which we call reality. And it's very powerful in doing that, but it cannot, it seems to me, it cannot be explained, really. I mean, maybe it can in different ways, but it just seems to me that whatever reality is that it's increasing in novelty and complexity always. And whenever we try to describe it in a confined way, it will simply present new phenomenon which will completely destroy that paradigm which we've created. There's a seemingly massive interplay between the thoughts, the mind, and the physical external reality. These things are not some sort of separate thing from each other. They seem to be extremely intertwined, and your understanding and your education should basically be giving you an insight into your own mind and how you think. And by doing this, it will consequently give you insight into what is going on with everything. And that sort of interplay between your own relationship with your own mind and your own mind's relationship with reality becomes a very, very profound, almost life-changing, life-shattering exploration, and really what education should be about. And it shouldn't really be about just teaching you inert ideas which are just given to you as true. And I'm being very clear here in that everything that I present to you on this channel is completely unknown, and it is a standard which is presented to you and accepted by society. But that doesn't mean that it's true. It's just very, very established. And a simple creative and critical thinker can see this very clearly. Anyway, just a little talk. If you like this kind of talking, I enjoy heavily talking like this, because this is really what I think about and what I work on most of the time. You know, doing these questions and doing this stuff, it's really for you. I mean, I also want to do it to, you know, help, and I guess that's kind of for me too, because it feels good. But I enjoy talking like this. I mean, I feel really authentic here. I mean, I do the questions for you. I do this channel for you. And so I hope that the work that I put out there is really helpful. But I am pushing towards a kind of new side of me, which I'm presenting now, which is basically this. I mean, this is just not unplanned, but if I plan this stuff out and really start to present to you what I'm actually thinking about, existence, education, reality, physics, mathematics, everything, past, history, future, everything, it becomes, for me, this is extremely interesting, curious, mysterious, strange, and it basically controls all of my thoughts. I can't stop thinking about this, because to me, the fact that I'm even here is miraculous. I can't believe it. Anyway, hope you're all well. I hope that video was helpful. I know I was a bit iffy on some of the questions, but I pulled through and did it. I'll upload the worksheet as well in the description. Yeah, but that's it. Thank you for watching. Bye-bye.